Hi, this is section 3.4. 3.4 is about 3 dimensions. It's the Cartesian coordinate system, 3 dimensions. You've probably done this sort of thing before. This is really designed to be an introduction. In future classes you'll get into a little more complicated stuff, but we start off with just graphing a few points and then looking at a few regions. Okay, so 3.4, rectangular coordinates in 3 dimensions. We're doing this expressly for the purpose of then looking at 3-dimensional vectors. All right. First of all, we're going to have an x-axis, and it's going to come out of the screen. If you'll think of it, it's coming out of your paper or coming out of the board. Then the y, which is going to be over to the right, and then z, which is going to point upward. Now, all of these are at a 90-degree angle to each other. And to graph a point, the points are now going to be in the form x, y, z. The first value being how far we come out on the x-axis, the second being how far we go left or right on the y, and then z up or down. Okay? For example, if I wanted to graph the point 2, 3, 4, I want to come 2 forward on the x-axis, then 3 right on the y-axis, then 4 up on the z-axis, and that gives me my point 2, 3, 4. You can kind of imagine it being out in space, 2, 3, 4. Okay, the distance formula in 3 dimensions, very similar to the distance formula in 2. It's just that instead of having just the x's subtracted and squared plus just the y's subtracted and squared, we now have plus the z's subtracted and squared. Okay, so the square root of the difference in the x's squared plus the difference in the y's squared plus the difference in the z's squared. Now you'll notice with the distance formula, it doesn't really matter which order I go in as far as do I do x2 minus x1 or x1 minus x2. It's not going to matter because you're going to square that value anyway. So just make sure you subtract the x's, subtract the y's, and subtract the z's, square those values, add them together, take the square root, you're set. Also, we wanted to look at the midpoint formula. Now for 2 dimensions, I only needed to average the x's and the y's. But since I'm in 3, I need to average the x's, average the y's, and average the z's. Okay, so x1 plus x2 divided by 2, y1 plus y2 divided by 2, and then z1 plus z2 divided by 2. That gives me my midpoint formula. Okay, next I wanted to just look at a few examples that you'll see in this section. If we limit x to where it is between 0 and 4, including 0 and 4, and then y with 1 and 3, and then z's between 2 and 3. What you're essentially going to define here is a box. Now you could go and draw that box. That would be perfectly acceptable. More in this section though, because this is an introduction, we won't do quite as much graphing. Now it is good for you to go through and maybe say, well, what happens if I say x is only 3 and then y and z can be anything? What do you get? Well, you're going to wind up with some planes instead of just lines like you did in 2 dimensions. But it is good to go through and kind of play around with the values a little bit and see what you get. But in this particular one, I'm just going to define a box. X is between 0, 4, y between 1, 3, z between 2 and 3. And what I want to be able to do is find the point closest to the origin. Now again, this is an introduction. So the way that these are all going to work is that you choose the x value that's closest to 0, because the origin is 0, 0, 0. So I'd want to choose x equal to 0. Then I want to choose the y value that's closest to 0. Then I want to choose the z value closest to 0. So I wind up with a point 0, 1, 2. Not too bad, right? All right, next. What if I wanted not the point closest, but the point farthest from the origin? Okay, well, similar idea. I want to choose between 0 and 4 the value that's farthest from 0. So how about 4? Sound good? Then what about between 1 and 3? 3 is farthest away, and then what about between 2 and 3? 3 is farthest away. So that point 4, 3, 3. is the farthest from the origin. Okay, and then the last example in this section that I wanted to do, I have x between 2 and 5, and then y is between x minus 1 and x plus 3. Z is between 2 and 3. So I've changed things a bit here on you. I left z the same. Z is still between 2 and 3. And now I have y dependent upon x. So I'm going to choose my x value first. That's going to determine my y values, because y is dependent. Okay, let me show you what I'm talking about. If we want the point closest to the origin, okay, now x is between 2 and 5. I want to choose whatever's closest to 0. 2 is closest to 0. So I'm choosing a 2. I now want to plug that 2 in for x to determine the y. So I'd get 2 minus 1 and 2 plus 3. So y is between 1 and 5. Okay, now specifically what I did was I took my 2, I plugged it in for x, so I got 2 minus 1 and 2 plus 3, so y was between 1 and 5. Now y is going to vary, though, if I had chosen a different x. So each time you choose a different x, you do need to redefine your y region. Okay, so I would want to choose whatever's closest between 1 and 5 to the origin. So I'd choose 1, of course. Next, choose z equal to 2. The closest point to the origin is 2, 1, 2. Okay, if we'd wanted the point farthest from the origin, I would choose x equal to 5. Plugging that 5 in for x, I get that y is between 4 and 8. Again, I took the 5, I put it where the x's were. So y is between 4 and 8. Choose y equal to 8, and then z equal to 3. That point is 5, 8, 3. Okay, so that was section 3.4. 3.4, like I said, was an introduction to 3 dimensions. Go through and mess around a little bit with what happens if I define this to be that, and if I define that to be that, and so on. Take a look at the XY plane, the XZ plane, and the YZ plane. Make sure those make sense to you. And like I said, this being an introduction, you're not going to have quite as many homework problems in section 3.4 as you will, of course, in section 3.5 coming up.